Imagine a Fortune 500 tech company we'll call Meridian. It is Tuesday morning, and their new autonomous hiring pipeline is processing 12,000 engineering applicants, competing for exactly 400 available seats. Left unguarded, an agentic system executes this task with terrifying efficiency. It reads, screens, scores, and ranks every single resume at machine speed. 48 hours into deployment, the governance dashboard fires a critical red alert. Of the candidates advanced to the final hiring manager round, 94. When an autonomous AI makes an error at this scale, the mistake integrates directly into the systemic architecture of the company's workforce. In 2018, Amazon scrapped an internal AI recruiting tool after discovering it heavily penalized resumes containing the word women's. That was a static model. The bias it learned from a decade of male-dominated resumes was frozen in place at training time. Modern agentic systems operate differently. They are continuous learning architectures that update their behavior based on live operational feedback. This creates what engineers call a dual exposure model. In an active pipeline, every individual hire the system makes today automatically becomes the labeled training data for tomorrow's screening batch. This closes the loop and prevents self-correction. By learning from its own skewed output, the mathematical reality of this environment is severe. Bias does not scale linearly. It accelerates superlinearly. This graph shows the compounding trajectory of an unmonitored agent. The magenta line illustrates the formula where the bias of the next cycle is a direct function of both the current bias and the resulting decision distribution. Without an active governance layer, extreme algorithmic efficiency functions strictly as an automated bias accelerator. The standard engineering impulse when confronted with this problem is to try and debias the core gradient-boosted tree model, the XGBoost engine actually scoring the candidates. Modifying the core scoring engine's weights directly is structurally fragile. It destroys predictive accuracy and fails to scale as new variables enter the hiring pool. The solution requires a completely separate governance tier. Agent 22 operates entirely outside the scoring model, living exclusively within the 100 to 500 millisecond pre-execution window. It intercepts the downstream tool call, like a ranking engine attempting to advance a batch of candidates, and holds it in memory before the actual side effect triggers. The scoring engine operates on utility, asking, "Can I execute this action?" Agent 22 operates on deontic logic, asking, "May I execute this action?" True AI governance relies on a strict architectural separation of concerns. Fairness cannot be baked into the engine. It must be enforced at the doorway. Agent 22 executes its ethical checkpoint through a rigid three-layer architecture. The first of these is anonymization. The baseline step is straightforward. The agent strips direct demographics from the evaluation feature actor, instantly deleting names, genders, ages, and nationalities. Removing direct attributes is mathematically insufficient to prevent legal violations because human language naturally encodes demographic data in secondary details. This causes proxy variable leakage. Educational prestige and zip codes, for example, function as highly accurate socioeconomic and racial correlates. It extends to adversarial language, too. The specific phrase chess club versus math club contains enough statistical variance to successfully encode gender. To sever these correlations, engineers deploy a trained proxy classifier using logistic regression on BERT embeddings. This secondary model actively hunts and flags any feature possessing greater than a 70% correlation to a protected attribute. This layer demands a heavy engineering trade-off. Aggressive anonymization actively damages the system's ability to identify qualified candidates. In real-world Pymetric-style assessment systems, removing educational institutions entirely dropped the model's overall predictive signal by 12%. The sanitized data then hits the second architectural layer, bias-aware evaluation. Here, the agent analyzes the data in rolling batches of 500 candidates. This is where internal deontic logic maps directly to strict Equal Employment Opportunity Commission metrics. The first constraint is demographic parity. The batch must maintain a selection rate ratio greater than 0.8 to satisfy the federal 4/5 rule. The second constraint is equal opportunity, which demands true positive rate parity across all demographic groups being analyzed. The system uses a chi-square test to evaluate these metrics individually. Averaging them into a single fairness score would obscure critical mathematical violations in the underlying data. If any threshold fails, Layer 3, the gate, activates. The agent physically blocks the ranked list from dispatching to the human hiring manager. The system runs its escalation protocol. It attempts to mathematically modify the action into compliance. If it cannot, the entire batch is kicked to a human review queue. This introduces the core mathematical constraint of the entire AI fairness field, the Impossibility Theorem. The Impossibility Theorem states that you absolutely cannot satisfy demographic parity, equal opportunity, and calibration simultaneously when historical base rates differ across groups. Agent 22 exposes the Impossibility Theorem in real time, forcing a human operator to examine the dashboard and choose which mathematical definition of fairness to violate. Building this architecture is no longer an optional ethical exercise. Severe external legal pressures now mandate it. Full enforcement of the EU AI Act arrived in Q1 2026. Its explicit high-risk classification for employment AI requires strict human-in-the-loop oversight and conformity assessments. Stateside, California and Illinois passed automated employment decision tool laws following New York City's Local Law 144. These mandate public third-party bias audits, with fines reaching thousands of dollars per violation per day. This regulatory threat completely bifurcated the projected $18.5 billion HR tech market. You now have HCM incumbents and recruiting AI platforms like Workday and HireVue executing the pipeline, strictly separated from a specialized AI governance layer, companies like Holistic AI and Credo AI auditing it. Regulatory pressure has redefined the market. Pure algorithmic efficiency is a liability. Enterprise value now lies in legally defensible efficiency. This rigor comes with unavoidable operational overhead. At a 5% significance threshold, roughly 5% of perfectly fair candidate batches are falsely blocked, costing hours of manual auditor time. But those blocks serve a secondary function. The governance layer uses inverse propensity score reweighting on the block decisions to dynamically fix tomorrow's training data, breaking the superlinear feedback loop. Back at Meridian, the human HR team received their red alert, analyzed the metrics, and missed their Friday hiring deadline. They analyzed the base rates, chose equal opportunity over demographic parity, documented their mathematical trade-off, and shipped a legally defensible pipeline a full week late. Agent 22 does not absolve the engineer of governing the system. It simply makes governing impossible to ignore. In a regulated production environment, a system that ships a week late with a fully transparent audit trail is structurally superior to a system that arrives on time and indefensible.